All right, and we are going to jump in with our next section, which is titled Building REST APIs. And if you see here, let me refresh this page because I got rid of some of these dates. Or I didn't click save. The dates of fall 2020. Some of this has been updated. Not a big deal. But what it boils down to, new section, REST APIs, and there's a fair amount of resources that we're going to be going through. Some of this we've actually already been exposed to, Postman tutorial. However, certainly REST APIs are new. There is a quick video that I added to the YouTube playlist, APIs Explained. It's a great example of what an API is. It's a very high level. But if I were to summarize this video, and again, I do kind of recommend you watch it. An API is when I think of a method. Okay, when I think of a method that I write in my code, and I make that method available on a web server. So a website can call a method and make that method available to other websites, to other services. That's an API. So very broadly in my brain, right, an API stands for Application Programming Interface. Okay, you can see the actual definition. But what that is, what an API is a method that's available to be called on the internet, And so, for example, Facebook has an API, and they make their login API available to other websites to be able to use Facebook credentials to log into your website. And so that login functionality is all exposed by Facebook. They put that code public on the internet for other developers to use and other developers to call on their code to be able to log in. Google has the same thing. So Twitter has an API, right? And it gives access to certain parts of the Twitter code base, right? It's important to understand that just because Facebook puts some of their code available on the internet for other developers to use, that doesn't mean all of the code is available for use. And so, it is an important note that APIs are accessible to developers on the internet, but that doesn't mean that you can access all of Facebook's source code. You can just access the methods that they give you access to. And so, again, that's what an API is. It's the source code that different websites make available, whether it's Twitter, whether it's Facebook, whether it's Amazon. All these websites, they have public APIs that you can register to use and gain access to parts of their source code and build them into your website. Okay, so that's what an API is, and you got to understand first off what is an API before you understand what is a RESTful API. A RESTful API is so what does it mean to be RESTful? REST or RESTful, kind of basically the same thing, right? So whether you call it RESTful APIs or you hear it called REST APIs, same difference. Okay. That really just means that your API is working with data at the most basic level, right? So your API will work with data. And so what we've already done is considered a RESTful API. And what I mean by what we've already done, in the first week, we made a Node application, we made Express, and then we were working with Postman, and we were working with data at some endpoints. And so when it's a RESTful API, you typically have endpoints, and those endpoints, be it a URL, calls a method. That method is publicly accessible to the internet, aka the API point. So because an endpoint like a GET request at this particular URL returns a piece of data. Okay, that's ultimately what the restfulness means. It means it's at an endpoint and it works with data. So that endpoint is a URL, somewhere on the internet, and it works with data. Now, in the first week, we were working with data in an array, okay? And that data in the array was stored in the application. Most of the time, RESTful APIs don't just work with static data stored in an array. Most of the time, RESTful APIs work with databases. And so that's where we're going. I think of a RESTful API, really what this section really gets into is working with data out of a database and tying it in to some HTTP endpoints where you can say, hey, give me all the users in your system, and it returns those users out of the database. And so the kind of the point that I was starting to make here, there's a lot of resources for you to go through. There's no textbook with this class. However, that doesn't mean there's nothing to read. There's a lot to read. And so if you kind of go here, building REST APIs, these are notes that have been compiled by your instructors, myself and others, on what is a REST API. Again, I can kind of give you a high-level overview of how it exists in my brain and how I think of it. But the REST architectural style basically means there's HTTP because HTTP is stateless. And really, when I think of REST, the idea of a REST, I think of a method because it's an API, so it's a public method. And that method is just kind of resting there until it's called, right? That's the idea, that's the acronym, because REST stands for something, representational state transfer. Okay, so in short, REST is a public method that's just kind of sitting there waiting for someone to call it. That's why the acronym REST makes sense, because it's just sitting there in a restful state until a user hits that endpoint, which causes it to do some work. And so we talked about what is an API, what is a RESTful API, a lot of reading, that goes into more details. Again, it's going to be utilizing endpoints. It's going to be utilizing transferring data. It's going to be utilizing HTTP and all of the HTTP methods like get and post and put. And we've done it, right? So don't let this term of RESTful API intimidate you. We were already doing RESTful APIs in the first week using Postman and using arrays. Now we're just going to be making RESTful APIs using Mongo, and that's the only difference. And we're just kind of learning a new term of, what is an API, what is a RESTful API, client and server. We already, the client is your Postman or your web browser. The server is Express. Stateless, HTTP is stateless. There's more details that you can get into the reading here. And again, most of the time they're sitting at, these are your HTTP methods, and they sit at those endpoints. Okay. So when you start hitting these endpoints like API product list, getting a list of products, that is something that we've done up until this point. Only difference here is that we will be getting our data from a database and doing CRUD on a database instead. Another major part of REST is that you're working with data, and you send data from the server back to the client in a very uniform format. In today's world, that uniform format means JSON. And so we'll be sending data back to the client using this, res response dot status, 200 that it worked dot JSON, and packaging our data up in a universal format. And so again, please take the time, pause this lecture, do this reading. If you haven't already. Now, getting into CRUD, as you know, CRUD is a very academic thing, and it's also very real world. Like, the most basic thing you can do with your data is CRUD operations. CRUD stands for create, read, update, and delete. Probably the most simplified one is the read. When you go to Amazon and you search for a product and then you're applying filters and you're saying, give me the prices highest to lowest, but don't give me any prices greater than $50, or, the shipping has to be within 50 miles, that's all reading. And so creating new records, pretty straightforward. Updating records, pretty straightforward. Deleting records, pretty straightforward. The most complex and the most challenging one in a lot of ways is the read operations, because when you're hitting a database, you can apply all these filters and sorting, and users can search, again, with that Amazon search, you can search for data in all sorts of ways. And so reading is often, you think, oh, I can just select star from my database, but in real world application, reads can be, fairly complex. So when it comes to mapping your CRUD operations to your RESTful routes, when you're creating, a lot of times that's going to be put in a post. Now, some people put it in a put, but a lot of times when you got a web form interface, with text boxes and drop down boxes, so on and so forth, a submit button, most forms do a post, so that's what we'll do. When you're reading data, it's going to map to a GET request, updating, and deleting. So updating, again, an update can be a post, or an update can be a put, or an update can be a patch. So these are your HTTP methods on the right, and these are your CRUD operations on the left. Okay, now, that's a quick overview of RESTful APIs, what that is, what we're getting into. Next up is to connect to our Mongo database a little bit differently. Okay, and so already we kind of followed a tutorial on Mongo's website on how to connect to a database, and we're going to be making a few changes to that. And so oftentimes in my lecture, CRUD and REST, we already covered this information. What I want to do is essentially a code along. And what I started in the first week with my code along was like a pet walking application where I had dog walkers and I had customers, and I've switched like between 3 different computers. So let me see if I even have this repo and its current state. So let's see, issue tracker, I've got some lab. It does not look like I have my repo for my dog walking app, so I'm going to go to GitHub. And if you followed along with me until this point, you should have this application on your computer, which again, I recommend following along. So if I go to my repositories, and here's CRUD dog walker. So let's clone that onto this computer. And you can go ahead and open this repository up. And let's open this with Visual Studio Code. Now, I haven't touched this since the first week, and so certainly in the first week we weren't doing Mongo, so I don't have a database. But if I remember correctly, I've got dog walkers here, which is essentially what I need, and I've got my array of dog walkers. And so this is where we were working with an array, so I'm going to kind of refactor this and change where the information is coming from. Okay, so as we learned in the last video, what we want to do, since I just cloned this, I notice I don't have my node modules, so I'll just do npm install, and that'll bring in my node modules, not install. How about install? Okay, so that brings in node modules, and in my server.js, again, we haven't, let's see, I've got my start dev, so let's clear the screen, npm run start-dev and make sure this boots up. Okay, so we got listening to port 5000, and it says welcome to my home page. Not much going on. If I go to Postman, and dog walker app, let me close and save all. Save, close, save, close, save, close. Dog walker app, let's see, list all dog walkers. So here's my port. Now this is port 5000 we're running on. So somewhere along the way I changed it to 5002. So let's just do API walkers list, and we get our dog walkers back. Somewhere along the way I changed that to 5002. I'll change it back to port 5000. And if I do something like add a new dog walker, I got a full name and an hourly Billy Smith. Let's click that. We added Billy Smith. If I go back to list all my dog walkers, we could see we've got Billy Smith. Cool. Well, I don't have a database, right? So as I'm stepping through this, I go back to Mongo, and my project here called mflix, not the best project name because it's got all my sample data. If I browse collections, you know, here's a bunch of databases. Now I can create my dog walker database, and that's kind of at the step where I'm at. You can do that using Atlas. You can do that using Mongo Shell. So let's do that. Let's just use Mongo Shell. So I'll go to a command prompt and go to my overview. Let's go to connect via Mongo Shell, copy in, paste that. I'm gonna need my password. Okay, so now let's show DBs. Don't have a dog walker app, so let's use dog walker DB. Okay, now show collections should be empty because we don't have any collections, right? So back to our sample data, we've got Evan and an hourly rate of 20, right? So let's do DB dot And this would be what collection? So this would be the dog walker collection. So maybe we'll just call it walkers. Not the perfect name, but these are the walkers. Insert one and full name. Hourly rate. And if I'm not mistaken, I think I saved this in a script somewhere, but hourly rate of 20. Okay, DB walkers, insert one, acknowledge true. Now if I show collections, it created the walkers collection. By DB walkers find, and then you can see I've been added. Let's add another walker. Oh, I guess he's making $2 an hour. And let's add Don Pohl. And I guess he's making a little more than that. Okay, and if I do my find, I've got my 3 dog walkers. So my sample data is loaded. I have an array of 3 dog walkers. And if I go back to here, databases, browse collections, here's my dog walker DB. There's walkers, and there's my data that we just put in. Okay, now back in node land, let's go ahead and stop our server from running. And we're working with the MongoDB driver, right? So the command that we use, npm install, npm I, MongoDB. Let me close this package JSON, reopen that up. We have MongoDB here. And instead of putting our database logic inside of our Express server, right? So we installed Express from last time. Instead of putting our database logic here, normally what you want to do is you want to take that out. You want to extract, separation of concerns, right? So, HTML's point is for content. CSS's concern is for the display of the content, right? So it's very common in web development is to separate your concerns. And so when you have your Express server, that is your application tier, it is very common to extract the database logic out into a different file, if you will. So I'm going to make a file called database.js. And this is going to be where we keep our database logic. And so let me look at where I want to go next. Okay, we're going to start by kind of writing some code that we did already. We're going to import Mongo client from MongoDB, right? So in our earlier video, we did that. Let's import debug. And then we'll make a debug channel, right? Debug DB, debug the database equals debug app:database. Okay, so this is going to be our fancy console.logs, if you will, to help us troubleshoot. And we're going to make a a variable here. This is going to be a let underscore db is null. And so, kind of what we're going to do is we're going to manage connections. You want to make sure that every time you open a connection, you close a connection. Basically, you don't want to create too many open connections into the database. And so, for every client, you basically want one connection. You don't want one client opening 5,000 connections. Servers need to manage their open connections and not allow that to happen. That's all resources and can cause all sorts of issues. So we're going to use what's called a singleton pattern. And so we're only going to basically create one single instance of this object, of this underscore DB. And that's going to kind of guarantee us that we're only going to have one open connection per client. And we're going to write an asynchronous function. Again, in Node world, all of our functions, or many of our functions, are going to be asynchronous. It's going to be connect. And a lot of this source code can be found in the reading that I referenced earlier. In fact, I was on this page where you'll find this source code that I'm writing here. And so this says, hey, if the database is basically falsy, right? If the database is falsy, now null is falsy, right? So if the database is null, basically the first time this connect method is called, DB will be null, and we're going to pass in the database URL. Now, what did we do here? Well, for the database URL, kind of similar to what we did before, we're going to go into, let's see, database, connect. We're going to click on drivers because we're connecting in with the node driver. We're going to copy this and paste it here. Now, this is in a quote. And what this does not do is actually give us the database name. So let me kind of go here. Let me copy in my password again. If you're trying this at home, you're trying to hack my database, good luck. You're not on my IP address accepted list, so this is safe for me to do. So this is my database. I could even call this connection string. Okay, so there's my connection string. And the last thing I need to do, well, not the last thing, but I'll say constant database name. So that gets me into the cluster, but I need the database name as well, which we just called it Dog Walker DB, capital D, capital W, capital D, Dog Walker DB. And now we're going to use this Mongo client. Mongo client.connect. And this is our connection string. And then we're going to set our database equal to client.db and db name. So we're setting this object equal to the client, which is our Mongo Connect database. And so it's not giving us access to our whole cluster. It's just giving us access into that piece, into that database. And here I'll do debug database, and I'll say connected to database. And finally, our method will return the database. Now we put all this inside of a connect function, okay? And ultimately, just, you got to call that function, obviously. And so one of the things we'll do at the bottom of this file is we will export this connect function and call it inside of our routes. And so we've made a function. We haven't called that function yet. Let me just... I'm going to make another function called ping. And this is just going to make sure that we can connect. So we are going to call connect right here. We're going to connect to our database and try and ping it. DB command, and here's an object ping :1. So this is going to be how we're going to basically attempt to debug DB. We're going to say database pinged. So if we call this ping command, we're going to connect to our database and try and ping it. And maybe one thing that I'm going to do here is just go ahead and ping right here just to see if our connection string is working. So I'll boot up that file. And at the bottom here, I'm going to export my two methods, which are right now is connect and ping, so that I can call those methods from other files. Let's see if I do node database JS. What we get in return. Okay. Normally what this means is I missed an await command. So let me close and see if I'm making a mistake. Okay, interesting. So when I do a console log, it does say database pinged, which is good. My debug DB is not playing nice. And so it's my debug that's not working, my debug channel. Oh, I think I know why. Let's close and node mon database JS. Okay, we're still just getting my console log. That's okay. Database pinged is a good thing. That's basically what I'm looking for. Let me spend just another minute on the debug problem. I forgot, and I just remembered that because I just cloned this off of GitHub, I also do not have a .env file. .env. That's probably why my ports were different, but I'll say port is 5000, and I'll say debug equals app:*, and that is necessary. This line is necessary to get your debug channels running. And now, if I clear the screen, nodemon database, we're still just getting the console log. We're a step closer. So it's a thing of repetition for me, and so that's why it's always good to go back and do this stuff repetitively. I'm sure with you guys, the more you do something repetitively, the better. So when you have a .env file, you also have to import .env, and you have to tell it to configure itself, right? So let's bring in .env, import star We literally just did this earlier today. .env.config. So now we'll be in better shape. Still no. We're a step closer. Okay, so we were up and running. Here's kind of where it's at. So I'm going to keep this ping right here. If I clear the screen. Okay, so on server, okay, on my server, you notice I have a debug server. You know, obviously you have to bring in .env, you have to bring in debug, and .env is configured, you know, to, in our script package JSON, we say, hey, use .env right here. Notice if you don't use nodemon, you know, we're not really set up to display the same .env files. This is a different command. Node, obviously different than nodemon. So start dev, if I do npm run start -dev, there we get our debug channel running. And so this is kind of where we were at and what I wanted to see. Now, it's not showing you my ping because I'm running server.js. So maybe if I do node mon, let's bring in that. Let's just try this, and then database JS. Now we get connected to database and database pinged. So you need that switch. If I don't show, there's app database. If I don't include that switch, if I just say node mon database JS, notice we're just getting the console logs. We're not getting the database. Okay, problem resolved. We needed that switch. That switch is there on our start dev script. That switch is not there otherwise. But the important part at this point is that we are connected to our database and database ping. So kind of going back here, database pinged is here, and connected to database is here. Realize this ping calls connect. So by calling ping, it first calls connect, gives us connected to database. That comes out first, and then it pings the database and took 44 milliseconds to ping. And that was on our, that was on the command where we used the .env config. All good so far. Moving forward. Okay, so here we connect to the database, we ping the database, and here next, we're going to write a method to kind of read some data, because not only can we connect and ping, now we're going to write a method to read some data. All right, and so we are connected to our database. So far, so good. Now keep in mind, there's probably a better place to store this connection string. We could store it in a .env file. For right now, I'm not going to solve that problem right now. We'll kind of circle back on that. Excuse me. Let's go ahead and write another function. And this function is going to be to get all walkers. So it's going to be our select star. And here, very similar to the ping, we're going to go ahead and hit the connect method. And now we're going to write our query. And again, this is why last week I said, hey, you know, in this shell, we could use a different tool, but the shell's commands are pretty similar to the commands you'll write in JavaScript. And so here's that command in JavaScript. You're going to see how similar it is. we're going to await the data. This is going to be asynchronous. Now, I'll start with saying db.collection. This is a method, and I believe our collection is called walkers, lowercase walkers. So this is the first find, and then we say to array. And so a little bit different, right? Couple of things that are worth pointing out. Number one, in the shell, it was just db.walkers, db.walkers.find. Now in JavaScript, it's db.collection walkers. And so you can always kind of tell, again, in the Mongo shell, it was db walkers find. And then here, the command is db collection, and that's a method, walkers find. So you can always tell when you're looking up, online, are you looking at, a shell command, or are you looking at some JavaScript by this syntax right here? Is it db.collection, and then you pass the name of the collection to the method, or is it just db.collection.find? Now, it's kind of worth pointing out that this piece right here actually doesn't run the query. This find method returns what's called a cursor, and then it's not actually until you call to array that the data is actually returned. So you're kind of essentially building the query here, and then not until you call to array do you execute the query. Okay, so this cursor is going to be used to build a query, and you could do a lot with this. And you can actually apply filters in here and everything just like you did before. If you were to say full name and all that, but we're not doing that for this method. This method is a get all walkers, so we're not filtering our data at all. We're going to go ahead and get all the dog walkers, put it in an array, and then return that array. Okay, so notice this get all walkers is a function just like before. We haven't called that function. We're actually not going to call this function here, but we are going to export this to get all walkers here. Okay, now again, this importing and exporting of functions, earlier on in the class we did some JavaScript review on Free Code Camp, and we have yet to kind of finish that because there's that whole ES6 modules, but this is kind of a newer feature where you could say, hey, I've got these methods, and let's export these methods and make them available to different JavaScript files. And notice you actually don't include the parentheses, but you just say export get all walkers. Now here we have a walkers.js. This is going to be the file that we import that method, right? Because we're actually going to use get all walkers inside of the proper route, right? So here's our list route, and instead of returning dog walkers, which is just our array here, we're no longer going to use that array. So let's look at it from that point of view, right? So we exported our function over here, right? Get all walkers, and now we kind of go to our endpoints, which these are our express endpoints, right? This is all RESTful APIs. So our method is right here. It's an anonymous method, right? I say a public method. So this is the method available at a route endpoint right here. So this is the list route hit, and let's bring in our method over here. So how do we bring it in? Let's kind of go up here. We're going to import. I'm going to import the connect method and get all walkers from, and Keep in mind, how do you go up a directory? You know, we're actually 2 directories deep. This is coming from a database file that's 2 directories above this file. So we got to do // twice, and that gets us up to database.js. So we're going to go ahead and bring in these methods, get all walkers from database. And now, dog walker route hit. Let's go ahead and connect. Const db is connect. We can call our connect method. Okay, so we've imported our connect. That should, again, if that connection hasn't already been made, it would make it here. And let's make a variable to await. And now we call our get all walkers method. Now, you're going to see here our function needs to be asynchronous. And so we need to add async to our function call. So right here on our list, in front of the rec and res, we're going to add async. Okay, so in order to be able to use this await keyword, you got to add an asynchronous method here. So this list async await get all walkers, and now instead of returning the array of dog walkers, let's return the array of dog walkers from our database, walkers. Okay, so I'm going to comment out these dog walkers here because they are no longer what we want to use. We want to connect to the database, call our get all walkers JavaScript function, store that in a variable called walkers, and let's see what broke. So let's do npm run start dev. Okay, so we're listening on port 5000. We were able to ping the database. I no longer need my console log, so I can delete that. And I probably don't need that debug right there, and I probably don't need that one right there. I just really wanted to say database pinged. So if I save that, okay, now I just get one. It says listening, it says database ping. That's basically what I'm looking for. I can connect and ping the database. And if I go back to Postman, now I send the data. Now this data is coming from MongoDB. And we have written a RESTful API to read all the records from a Mongo database. So this is exciting, and yeah, we are on our way. Now, you know, we have to do more. We have to do the full CRUD operations, and we're going to write some more, you know, queries where we can actually filter by a user's name, or we could filter by, you know, maybe a user ID. But yeah, this is exciting. This is what we were looking to do today. So we are well on our way. Okay, so you know, these were some different routes that we had that we need to refactor our code. Now that we have list all dog walkers hitting from the database, we can maybe get a dog walker by ID. We can add a new dog walker. We can update a dog walker, and we can delete a dog walker. Now, each one of these, you know, is going to take its own database method, and so right here we kind of have a get all walkers. You know, we just need to write more methods that are similar in nature, and then each one of these will be able to over here refactor our code. So you'll notice here what we were doing is we were getting an ID from the query parameters, right? From We were getting it from the parameter now. So if I kind of go back to the get by ID, we were passing the ID up here. And we can write that. We can write that method next, or we can add a new dog walker. I suppose it doesn't really matter. Let's go ahead and do the get by ID. Now, the one thing that's unique is that a string ID, okay, now keep in mind these IDs, if we just go to list all. Okay, these IDs right here, they're not standard strings, right? Those are object IDs. And so one thing that we'll have to keep in mind, and kind of a problem that we'll hit, is if we just, kind of copy this ID up into here, probably that ID needs to be converted not just into a string, but it needs to be converted into an object ID. That way you get like a type match, and the types are the same, therefore it will return our dog walker by the ID. Okay, so that's something kind of to look forward to as we're writing this out. So let's go get dog walker by ID. And here, let's go to our database. This was get all walker. We can kind of follow async function, and we'll say get walker by ID, and we'll pass in walker ID. So this function is going to be a little bit different because we need to send in the ID that's coming in from the route, right? So we're going to read the ID here and then send that into our function. And once it's in our function, then we can use that in our query. So we'll say const db. Now this is an individual walker. Now a find returns a cursor, which you then say, okay, take that to an array. We're going to do a find one here. Await db collection. This is our walkers collection. Instead of find, we'll do a find one. Pass in an underscore ID colon $EQ, and this is where we say walker ID. Okay. And we're going to return the walker here. So here, you build this cursor, and then you take it to an array, and that to array kind of executes it. Here, the find one will execute the query. You pass in the filter of the ID equal to the walker ID that's passed into the function call. Now you do see that's kind of grayed out. That's because we need to export this to get walker by ID. So we're going to export our function. Of course, that means over here we have to import it. Get walker by ID. And kind of down here, we'll go ahead and bring the dog walker in by ID, walker route hit. I'm going to change this, and I'm going to say something like this with the ID. I'm going to cut that. Okay, so my debug, when I hit that route, it'll throw the ID back at me. Now, there is another step that's needed. Remember I said your string ID has to be converted to an object ID. There's a method that exists to help us with that. So over here, back in our imports, let's import object ID from MongoDB. So this is a method that we should be able to take that ID and convert it using object ID. Let's see if I remember the syntax. So go back here. Now here our find method is no longer that. I'll say const found dog walker equals, did I bring in my, yeah, get walker by ID. I'm going to pass in object ID, and so again, ID kind of comes in from the parameters, and we're going to pass that ID into get dog walker ID, but we're going to convert it. So this object ID converts that string ID into an object ID. And here, if the walker is found, we return the dog walker. Okay, so that's the tricky part. Now I'm pretty sure if I don't do this, let's just do that. Let's just send in the string instead of the object ID. And let me kind of go back here. I know that this is my dog walkers, and there is my, here you can see the data is not returned. Again, I think the problem there is because it's not an object ID, so let's bring that back. Now that we convert that to an object ID and reboot. Okay, and so this says what? Object ID cannot be invoked without. Doesn't like my object ID. 1 second. Oh, I might have to say new object ID. Clean this up here. If I say new object ID and go back. All right, let's take a quick look. So one thing that you can do to troubleshoot is, that's why we have the debug in there. And notice it is bringing in the string right here. And so get walker by ID. Now let me go back here, get walker by ID. DB collection walkers, find one. What I can do here is debug DB and pass walker ID. So let me see what it looks like when it's coming across over here. Ping that and empty. See, it is an object ID now with that string in it. So there's my string. There's my object ID. Now it is saying new object ID. And so I'm not a fan of that. The fact that it's saying new object ID. So I'm gonna maybe do one more line here. Const walker ID equals, and then here just back in walker ID. Okay, just refactor that a little bit. Same difference, new object ID. So here from the walker route, it's saying one thing. Over here, that's right. So it's making it to here and hitting my find one method, and this is not returning any results. So I made a mistake once that I've made 500 times before, and this is This is something I promise you will make. And it's always, it's nice when you find it, but it's a little challenging to go through. Now notice here on line 26 I called await get all walkers. So get all walkers is an asynchronous function. Therefore, when you call it, you must call await. And this is on my list. Notice on line 38, I did not await my my get walker by ID. Of course, this also needs to be async. I got to a point where here's how I was able to troubleshoot it. I went into my database JS and I saw that when I did a debug my walker right here, that my database was returning data, but it just was not being sent back from that point because I did not call on this await right here. And so the way I was able to troubleshoot this on line 38, I added this line 38, and what you'll see here is it was returning my dog walker. It was returning it inside of this database file. However, where does it go? It goes from the database file to my found dog walker and then back to the client in the response object, res.json found dog walker. This was coming back empty. So there was data over here in the database, but there was no data by the time it got back here. And so I was like, what am I doing wrong? Of course, you will hit that problem. So I have to await. Now that I await, I can actually comment these debugs out. This is why these debugs are very helpful, because you will run them in different parts of your JavaScript and it will tell you what part of the JavaScript it's running, and you can look at your data while it's running. You have to get comfortable and learn these debugs to be able to troubleshoot these kinds of problems. Anyways, point is, now if I kind of go back and I list all my dog walkers, this is coming from the database. And if I go to get walker by ID and I pass in this ID, this is my second dog walker, which is Charles Corrigan. If I kind of come back here and pass in my ID, I get Evan Gudmested. And finally, Don Pohl. The big thing on these IDs, they come across as strings. You have to convert them from strings. The way that I did that is with this new object ID, and I can simplify this here. If I just say new walker ID, or new object ID, like so. Okay, so that takes a string, converts it to an object ID, then when it hits the database, it's comparing the same data types and you're getting a data type match. Now, this instead is ID, right? So I read ID from params, I convert ID to a new object ID, run that again, we get our data back. Get it to the front end, that's where we want to be. Okay, as we're going through this, right, add a new dog walker, update a dog walker, and delete a dog walker. So now you have an idea on how to kind of filter by ID. Maybe we want to filter by name too. Again, these are all things we could do. I suppose next we'll add a new dog walker. So add walker in the database file. Okay. So as we're going through, we got our list all dog walkers, get them by ID. That's up and running. Let's do add new dog walker. Now, here in the body of the request, not in the params, we're going to send over a full name and an hourly rate. So if we kind of go back into walkers, let's see what it used to be. So this was the new route. And we went ahead and made a GUID with new nano ID. We'll just let Mongo handle the object ID. We don't necessarily need a nano ID here. And we say, hey, if there is a full name and an hourly rate, then let's read that information into an object, right? So let's read this properties out of the rec.body into an object, and then we did a push. Okay, so that's what it was dealing with an array. Let's do this now with a database instead. We'll write another function, async. We'll call it insert walker, new dog walker. So this function takes in that object that we're going to construct and send into this method. Let's connect to our database. Now, the insert one method will return a value. So if it successfully inserts a new dog walker, this insert one will return a value, and then you can use that value to determine if the insert was successfully done or not. But let's just return walker. Okay, so think about this method. We got an insert walker. We'll take in an object, and then we call the insert one command to insert that object into our collection of walkers. And this is just going to return some data saying successful or not successful. Over here, we're going to have to refactor this. So we hit our new route. We don't need a nano ID. We're going to check to see if there's a full name and an hourly rate. If so, it'll generate the new ID for us, because that's what Mongo does. We'll say, hey, go ahead and populate the full name, populate the hourly rate, parsing it to an int. And we're not going to be pushing. Let's bring in our method up top. I think it was called insert walker, if I'm not mistaken. No, we don't have insert walker. Insert, oh, we have to export. So in this file, we need to export insert walker. So we export that file, excuse me, we export that function. We import that function over here, insert walker. Now our application doesn't crash. And now we can say const result equals insert walker passing over our new object, which is new dog walker. And then you can do something like, here's what I'm gonna do. I'm going to debug walker router. I'm just gonna say result. I'm gonna say something like the result of the insert command is, and this is we'll do this a successful, just to kind of show what that data returns if it's successful. And then we'll res.send new dog walker added with the new dog walker full name. So over here, okay, so again, if the data comes across inside of the rec.body, different than rec.params. Params is part of the URL. Rec.body, kind of comes across from the form, but in this case it's from Postman since we don't have a front end form, and we have to have this line in order to do that. Again, so the body has two pieces of information in it. Make an object, send that object into our method called insert walker. Oh, almost made the same mistake. Await, therefore this method needs to be async. Almost made the same mistake twice. I will make it again in the future, I promise. New dog walker added, else. Okay, so let's go over here. We got Billy Smith and 500. I click on send. New dog walker added, Billy Smith. Now just to go back to my route, now that's object. So I need to kind of parse that a little bit because it sent an object back. There's going to be some properties that you can kind of say result dot and take a closer look. But at least on the surface, it does look like our insert command worked. Now what I'll do is I'll go back to list all dog walkers, and there I'll see Billy Smith exists. Now you can close this application and restart it. This information persists in the database. In fact, if I kind of go back here and refresh, we should see our new dog walker added. There's Billy Smith, hourly rate of 500. Awesome. So you're starting to see a pattern here. And what's next? So we can add a new dog walker. Maybe we update the dog walker. The update command is slightly more complex than an insert. So what do? We pass the ID up here. So we have to convert that ID. So we have to, if we're going to pass it by the object ID, we need to convert that from a string to an object ID. And in the body, we say, okay, well, what's the new information that we're going to update it to? So let's go back to our database.js file. Write another async function called update walker. And here we need two pieces of information. Is the walker ID, because that's going to be part of the update command, and updated walker object. Right, so this is an updated walker object, and this is a walker ID that we're going to use in our query. Const db await connect. And const walker await db collection walkers, and update one. Update one takes two parameters. And then return the walker. Now, two things here, right? So we need to search by the ID, so _ID colon $EQ walker ID. So that ID is going to have to be converted into an object ID. And now this is, again, this is a newer feature of ES6. This is the spread operator. You do ... updated walker. And so this is really interesting syntax in that it will this returns an object right here. And so you know the dog walker's information will have properties and values. And then this will say, hey, you know, update, this is what to update. If it matches, then it doesn't do an update. But if there's a newer value, like you update the name, for example, it will apply that update. And so, yeah, this spread operator will take an object and break it down into its pieces, and then it will basically compare. It's like, hey, if it needs to do the update because there's a new value, it will update that field. Otherwise, it doesn't. And then also we can add a last updated property to a new date of today. And so let's see, that closes that, that closes that. Oh, I missed one set of curlies. This is $set : close that curly brace right there. So that second object needs to be $set, spread the updated walker. Ooh, I'm sorry, updated walker. That's this guy right here, updated walker, and add a last updated field to a new date. Okay. Now we need to export update walker. And we need to bring it in over here. Update walker. And we need to go to our update route. So you get the ID that comes across from the rec.params. That's the same. Now let's see what this did before I jump too deep. Okay, got the rec.params. This queries our old array that doesn't exist anymore for a dog walker by its ID. And if it finds it, then we destructure the rec.body, pull out those two pieces of information, and we say, hey, if there's a full name, assign the full name. If there's an hourly rate, assign the hourly rate. And we say dog walker updated. Okay. So here's what we'll do. Gonna restructure this a little bit. I'm just going to comment it all out, right? So it's less confusing. Just going to comment all of that out. We get the ID. If rec.body.fullname and rec.body. Now, actually, let's just bring this out here. So now these might be null because you might not update both. Right? One of these might return null. Let me think about this for just a second. Instead of pulling the properties out, let's just store the whole thing in an object, because that's ultimately what we need to send to the next method. So this is updated walker. So again, the rec.body might have, one property or multiple properties, but here updated walker object equals the rec.body object. And so now we're going to, let's bring in, did we already bring in the update walker? So we need to call update walker. Const result equals await. Of course, this needs to be async. Update walker takes in a walker ID, so I'll say new object ID, comma, updated walker. So we pass in the ID, updated walker, result, and let's just do a debug walker route, walker updated, just put that result back in there, and now we got to send res.json. We don't have much error handling right now. Res.json, or just a res.send. It's interesting here, res send, we're just sending. Here we did a res.json, so res.json found dog walker. So whether we're just sending a message or we're sending the JSON back, like res.status 200.send. Okay, we need to put in some error handling, because right now we don't have any controls for errors. But let's see what breaks. And so if I list all dog walkers, let's grab Billy Smith here and change his hourly rate. So we're going to update dog walker. We're going to pass in his ID here. And hourly rate of 62. Now that says walker updated. And there it goes. Billy Smith, hourly rate is 62, and it has a last updated. It's a new property. This says last updated. And so you kind of put that in there for the some of the labs that we'll do require a last updated property every time you update a piece of information. Now, if you kind of pass an ID that doesn't exist, you might put in a little error handling. into this to say is Walker found, and here you can get Walker by ID, new object ID, if is Walker found, then you go ahead and do this, else we could say res.status 400 dot send Walker ID not found. And so if I go up here and I go to update dog walker and I pass in a 6, that should give us a not found. Now it's giving us it's saying Walker updated, which is not correct, because I would expect this so I need to debug Walker router is Walker found. That's not coming back falsy, that's coming back truthy, which is why that's doing that. And if I look at that, it says Walker, oh, I need to await. Await, it got me again. Now, you put in a bad object ID, now it says Walker ID not found. There we go. Now it's coming back null. That's why my if statement is not working. Those database methods, put that await in front of it. That's been the every problem I've had so far. Okay, it is 11:50, so we've been at this for a few hours. We're going to go ahead and take a lunch and take a little break. And when we come back, we have a delete method, which should not take too long.
All right, sounds good.
And so returning from lunch, we have refactored our code to no longer use an array, and we are using a database for our list, get by dog walker ID. We have a post a new dog walker that's working in the database. We have an update, which is a post. And really the last thing that we have, well, we're going to do some cleanup and a delete. And so let's take a look. The delete, we're going to pass the dog walker ID in through the URL. And so we're going to read that out of the params, rec.params. And we're no longer finding an index. And so really we just need to write our method to delete inside of our database.js. And so like our other methods, here's our update. Let's go async function delete walker, and we're just going to pass in a walker ID. I want to show a method that, again, is in the reading, that can kind of be useful here. You know, in this reading, it really kind of goes through a lot of what we've done in this CRUD, at least in this lab, you know, bringing in Mongo client and pinging, and we haven't done anything with this config package yet. So when I talk about cleanup, I want to kind of circle back and look at this config package. This is that singleton pattern it talks about. Okay. To avoid requiring MongoDB in every module, I usually define the following function in my database module. Okay, so let's take a look at this function. This function inputs a string and returns. This function is called new ID. Now this is, you just got to keep in mind, this is a syntax for declaring a function. It's a newer syntax for declaring a function, so it's a little funky. But the function identifier is new ID. The function inputs a string and returns that string converted as an object ID. Okay, so I want to just kind of show you, if I bring in this function into my database module, CRUD.walker, okay, and you know, I can just kind of paste it as simple. It's a simple method. And again, it inputs a string and returns that string converted to an object ID. And in order to do that, I need to have object ID imported from MongoDB, so that's recognized. Okay, so now I have this function called new ID, and if I say const ID equals new ID walker ID, this function returns that string converted into an object ID, right? So now ID is in fact an object ID. Does that make sense, Grant? Did I explain that well enough?
Yeah, I get it.
Okay. So now that we have that in an ID, we can go ahead and say const walker, or walker equals await db collection walkers delete one with an ID underscore $EQ. And here we just put ID. So we can send in a string. We can call delete walker and just send in a string here, convert it to an object ID, delete, and then return walker. Again, getting this working first off, then I want to clean a lot of this up because this is kind of a little bit all over the place with everything. So there's my delete walker method. And if I go over here, delete walker, export it. And then over here, we can import it. Delete walker. And now on our delete route, I'm going to delete a lot of this old code because it was there. So now we have a string coming from the rec.params, and we could say something like, again, validation is what I'm thinking here, but const result equals delete walker, pass in the string, and then result's going to give you something back. Again, I got to validate this, but let's just go ahead and say if result res status 200 dot message send a little walker deleted. Again, we need to validate. This is a very rough draft, so delete walker by ID, pass it in. Let's go here and copy. So we want to delete Billy Smith, and let's throw in Billy Smith here and send. Now it says walker deleted, but again, I have no validation, so I've really, yeah, no way of testing that. No, it says DB is not defined. So is await DB collection I forgot to connect. So const DB equals await connect. Reboot that and go back. List my dog walkers. There's Billy Smith. AA5 is his last of his value. That says walker deleted. Now he's no longer there. So I go to list all dog walkers. So my delete's working. Got some cleanup tasks to do, but that is a functioning RESTful API working with Mongo Atlas DB. Okay. Now the next thing to do is, again, there's more to this lecture, but this is a good pausing point for the moment. We'll be right back. Okay, now that we've got CRUD working, the next thing I want to introduce is another package called config. And right now, at least today, this morning, we took our connection string and we stored it in the .env file. And that's okay, and certainly that's what a lot of people do. There's another package here called config that you can take connection strings and different settings and have different settings in different environments. Okay, so for example, you might have a different settings in your development that you have in your production. And so there's a config package that allows us to have different settings in different spaces, even though our code, again, when we're developing on our machine, that's kind of one code base, and then in production is another code base. It allows you to have just different settings in different environments. And so here, just kind of to go through this, using the config package to manage connection details. It says the code examples above are hard-coded database URL and a database name. It's kind of what we have right now, right? We have hard-coded database URL right here and hard-coded database name right here. However, these bits of information typically need to be configured from machine to machine, environment to environment. As such, we need to extract these values to a configuration file to allow them to be overwritten via environment variables. To facilitate this, we will integrate config. Now again, config is not necessary. In fact, I know, we can do a lot of this just by using .env. But we're going to benefit from this package the more we go through the class and the different environments that we find ourselves deploying our code in. So the first command for config is npm install config. And let's do that. So I need to Control C npm I for install config. Config uses JSON files to define and store your configuration settings. Your config files must be located inside a folder named config in the application root. So as that says, let's go ahead and create a new folder called config. And inside of config, now these file names are very particular, so I'm going to copy and paste from this file. I recommend you doing the same. Custom environment variables.json. And so again, this is a link on the homepage of Inside Rankin. Scroll down to find this. If you want to type this exactly as is, you can do so. But let's just do this. And inside my config, I'm going to say custom environment variables.json. Okay, now there's actually going to be 4 files here. Again, this is all on the docs. So there's production JSON. Let me alt tab back and forth. So I'll make another new file inside of config, production JSON. Make another new file, development.json. I'm just saying it's easy to make a typo. And default.json. Stores the default settings for your project. Okay. Now for right now, inside of production, we don't have anything special that we need in production. We're not, same thing with development, we're not doing anything special here. So just kind of empty JSON objects for right now. So let's type in default JSON. This is an object, and let's see. Let's copy this. Get that last curly. Copy that. Okay, so right now, localhost port 5000 is what we are using for our server HTTP, our web server. Our database URL is not a local host. So our database URL here, we're going to cut that connection string and paste right there. Actually, we'll come back right now, DB URL. And the comma name is the DB underscore name. So it's going to be kind of the config package is still going to be playing nice with our .env. So our .env, we need to go ahead and take in our database URL. And this is database URL equals, and this is where we cut and paste, very similar to what we did before. And our DB name so let's make a DB underscore name here equals, and I'm DB dog walker, so I'm going to cut and paste. I should have done this one step at a time. I tried to do two steps at once. So now we've got these two environment variables. Now if I just kind of go back here and I say process.env.db URL, okay, and then here I'm going to say process.env.db name. Okay, now I'm not doing anything with config yet. All I've done is I've extracted the name and the connection string into my .env. And I'm going to boot this up, npm run start div, npm run start dev. So I do want to take this kind of one step at a time. And so it did ping my database. So we extracted the connection string into an environment variable and the database name into an environment variable right here. Okay, and if I kind of go back here and I list my dog walkers, we're still add new dog walker, list my dog walkers, there you go, delete my dog walker, walker deleted. Okay, so that's one layer of extraction. Now here, this default.json says, hey, there's a DB URL and a DB name inside of this config package. You can literally copy and paste this. Except, so I'm going to copy this here and paste it into custom environment variables here, and instead of host, so our host equals localhost, and then this becomes host name. Host name. Host name. Host colon host name. Port equals port. So this custom environment variable says, okay, get the host from the host name, the port from the port, the URL from the URL. So this custom environment variables reads from .env. All that's up and working. Database is still pinged. What this allows us to do, Again, we're just kind of moving around the connection string a little bit. Right now our connection string is saved inside of the .env. Back in our database file, now instead of reading out of the .env, I should be able to import config. And now instead of reading this here, I should be able to say config.get db.url. And db.url reads from my environment variables. Same thing here, config.get db.name. And db.name here. Arguably at this point, we don't need this config package, but as we go forward and do different things, it'll be nice to have it integrated. When it comes to like, hey, this is what I want to happen in development. These are some settings in development. These are some settings in development that are different. We can make those modifications. Arguably, I could just delete this stuff because these two files are really just using our .env, and we don't need another layer. But we're kind of just setting ourselves up for the future as we get into deployment and those kinds of things. But this should all still be working. And again, if I kind of go back and list my dog walkers, get a dog walker by ID, we're still working. Okay, so as we're kind of wrapping down on the lecture, just trying to make sure I hit all the notes in this document. I did mention that the find method, collection.find, returns a cursor, right? Which is kind of when I think of a cursor, I think of a query builder, right? And so when we were building queries last week on Mongo, we were doing things like, hey, don't give me the customer and all their fields, just give me the customer name and customer budget. So you can call a find and then do a project, and using that project you could say, don't give me all the fields, just give me some of the fields. So again, you're building a query. You can sort, you can limit, you can skip. There's all sorts of things you can do here. There's also the toArray. toArray is what we use. We just said find.toArray. And what this does, the way that toArray works, is it returns what's called a promise for your documents. And so it doesn't return it immediately. All of the information, the query runs out of the database and it gets stored in your server's RAM. If your query is large and you're selecting millions of records, to say give me all the records at once and put them into an array might not be the most efficient way of loading the data. And so there's some other methods here that don't wait for the entirety of the data to load. Again, if you have millions of records that you're returning, that's going to be a slow query. And so you don't have to call find toArray. You could do find.next or find for each. And these return, maybe one document at a time, or, a stream means more like a little bit of data at a time. Think of a streaming TV show, right? The information gets sent across the wire as you need it. It's not like you got to load the whole, hour-long Mandalorian in memory. It's streaming bits at a time and consuming those bits. So toArray is useful because it's easy, but there are other methods on this cursor API that might be more efficient that we'll work with. And so, kind of an example here, here we're doing a find method when we're saying, hey, only give me the name field, only the names of the pets, and sort them by the name. And so we can kind of do a little bit of that. Now notice now they're doing cursor.next, which is going to get you one record at a time. And it says, hey, while that cursor.next is returning a record, continue to loop and print out one record at a time. Okay, so you're not waiting for all the data to load in this scenario. Instead of saying dot to array, we made this variable called cursor. We kind of built our query, and then we executed our query one record at a time, and then spit that out. Okay, so that's an example of working with cursors. We did this quite a bit already, with projecting and sorting, working with Mongo, just keeping in mind the syntax is similar, just a little bit different. So you've already been exposed to this kind of logic, but you were writing it in the Mongo shell, and this is just the JavaScript world, which is similar, but just a little different. Again, that's the benefit of learning it in the shell, is it's pretty close. We got aggregate pipelines, so just the same way. So here is an example of a query that we've written, right? In Mongo shell last week, we would have wrote an aggregate pipeline like this inside of an array. And this is the equivalent in JavaScript. We load up our cursor. We call db.movies.aggregate. And I mean, it's practically the same code, except for here now we call our cursor to array to get the movies out. Again, you don't have to use to array. You could use some of those other methods that we just went through. And you can see it gets more complex. Okay, we went through an example on how to insert one. If this was an array of pets, you could do an insert many. We did updates. Delete one and delete many. Okay, now here is kind of where I want to stop for today. The next package we're going to talk about does more with data validation. There's a package called Joy that's a really useful package for validation, but don't have to get into that today. We made a lot of good progress today. So I'm going to save this where it is and go ahead and push it to my repo, and we'll continue tomorrow.